So this is technically the second video on this homework. On the other video, I explained question 1 and question 5. So I want to explain some other ones here. I want to start with question 4 on this video. So what I recommend for you guys to do is to ignore h and k. We don't even have an h, so you just box in that, ignore the k value. The k value is -1. You already know that your asymptote is -1. But it should be written as an equation, y equals -1. So that what it means is that after we graph the parent graph coordinates, we're going to shift them all down by 1 unit. Okay, so I box in the parent graph, I do an xy table, I plug in consecutive integer inputs. So we need to make sure that we plug them in order. The negatives, -3, -2, -1, 0, 1, 2, 3. And then plug in 0, the easiest one, and 2 to the 0 is 1, and 1 times 1/4 is 1/4. So when we plug in 0, we get out a 1/4 or a 0.25, whatever you want to call it. But that is a coordinate on the parent graph. Okay. Now, I could plug in the number 1 right there and then do the math, or I could simply take the output 1/4 and multiply it by the growth factor, which is 2. So if I take 1/4 and multiply it by 2, I'll get 2/4, and 2/4 reduces down to 1/2. And then if I take 1/2, and then if I multiply it by 2, I'll get what? 1. And if I take 1 and multiply it by 2, I'll get 2. And you know what? Since it's so easy, I might as well keep going. Let me do a 4 and a 5. Let me do a 4 right here and a 5. So what would the next output be on the 4? 4. And the next one? 8. Because we are multiplying by 2. So we see that the growth factor is 2. That's why we multiplied by 2 as we go down. Going backwards, it'd be like multiplying by 1/2 or dividing by 2. 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. 1 divided by 2 is 1/2, divided by 2 is 1/4. Now, it's really kind of silly to do the rest because you already know that it's going to approach 0. Whoa, 32. So let's graph what we have on the parent graph, and then we're going to have to shift the whole graph, moving it down 1 unit. Does everybody understand that? Now, we could, instead of graphing the entire parent graph and then shifting every single coordinate down by 1 unit, we could do the numeric shift right here on these y values. Okay, we could if we wanted to. So what do I mean by that? I could actually take 1/4 and subtract 1 from 1/4, and I would get -3/4. So the actual coordinate over here is going to be 0, -3/4. Or I could subtract 1 from this, and the actual coordinate would be 1, -1/2. Or I could subtract 1, and that would be 0. Subtract 1, that would be 1. Subtract 1, that would be 3. So you could end up with your final coordinates, so you don't have to do the shift by subtracting 1 on your y values. But I like to actually show the parent graph and then the shift of moving every single coordinate down 1 unit. So let me start by graphing 0 and 1/4. So 0 on the x, it doesn't move left or right, and 1/4 of the way up. It's not even halfway up, it's super close to 0. So let me put a dot there. 0, 1/4 is right there. Then we go to the next coordinate, 1, 1/2. 1 and then halfway up. Whoops, that's not halfway, let me fix that. Halfway up is about right there. Now if we go to the next one, 2, 1, that's a nice coordinate, it's right here, 2, 1. Again, I'm going from the origin. I know it's kind of hard to see the origin on this graph, but you go 2 on the x, 1 on the y. Now the next coordinate is 3, 2. So from the origin, if I go 1, 2, 3, and then up 2, I'll end up right here at this point. And then if we go 4, 4, so we're at 1, 2, 3, 4, up 1, 2, 3, 4, I'll end up at this point. And the last one, 5, 8, it'll be way up here. So we see that from left to right, it's definitely growing, and that makes total sense because it is a growth function. The base is 2. So going in this direction, it's going to shrink, keep shrinking down to 0, and this is only on the parent function. Now, I'm not even going to draw it. I'm just going to draw dots on the x-axis because I know that I need to take this whole graph and move it where? Move it down 1. So my new asymptote is going to be down here, or the new tail end of the graph will be down there. If I move all of them down, so if I take this one and move it down, if I take this one and move it down, take this one, move it down 1, down 1, down 1. Every single one, down 1, I will have my final graph right there. And if you do happen to draw both of them like I did, I would put an X on the dotted red one. That way we don't confuse that with the actual graph. So I will at least give you 2 graphs to do on Friday on the test. Okay? So we want to practice all of these. That was exponential growth. Oh yeah, we need to state everything we can about this blue graph that we just did, this exponential growth function. So the domain, let me put D, x equals all real numbers. The range, you're talking about your y values, they have to either be above a certain value or below a certain value. And it's that certain asymptote value. And there's the asymptote. We already know it's y equals -1. So y is greater than -1. Because this blue graph is above the y value of -1. So y is greater than -1. That's the domain, that's the range. We already said the asymptote. And the other one's the Y-Intercept. The Y-Intercept's a little tricky because the Y-Intercept on the parent graph was 0, 1/4, but we need to subtract 1 from that 1/4. So if you go 1/4 take away 1, or -1 plus 1/4, you will end up with -3/4. So the Y-Intercept is 0, -3/4. Yeah. So I'm thinking maybe I'm explaining things too fast.
Yep, just a little bit.
Okay, I want to slow it down on this one so we could all make sense of it. Now, again, I say ignore your k value. Just focusing on this right here. And then make an xy table. And then go for consecutive integer inputs in order from -3 to +3. We might not use all of them. And then I say plug in the easiest input, which is what?
0.
Okay, take that 0, put it right here. Again, we're ignoring the k value. We already know we're going to shift it down 6 units. Put a 0 right here, and you're going to have 1/3 to the 0 power. Anything to the 0 power is equal to 1. So you really have 1 times 6, which is 6. So for the input 0 on the parent graph, not on the whole graph, but on the parent graph, for the input 0, we get the output 6. Now, this is where it gets interesting. You could plug in 1, and then plug in 2, and then plug in 3, and then plug in -1, but that would take you way long time, right? A long time. So the easier thing to do is to recognize that the decay factor is 1/3. If it were a value greater than 1, it would be the growth factor. So what you have to do is take the 6, and then you have to multiply it by 1/3, and you'll get the next output. So let me actually show that math right here so nobody gets lost. 6 times 1/3. So we have 6 times 1/3. Yeah, when you multiply fractions and with the whole number, put a 1 underneath the whole number. So 6 over 1, and go 6 times 1, that's 6. 1 times 3, that's 3. That's 6/3. But what is 6 divided by 3? That is 2. So let's go back to our table, and when we plug in, or when we multiply 6 by 1/3, we get out a 2. So once again, we got a 2 right here. And then I need to take the 2, and I need to take that 2 and multiply it by 1/3. Now remember, if you put the 2 over 1, and then multiply it by 1/3, what do you get? 2/3. So you're going to get 2/3, which is less than 1, right? It's a fraction less than 1. Now, if you take 2/3, and if you were to multiply it by 1/3 again, what's 2 times 1? It is 2. And what's 3 times 3? It is 9. You get 2/9, which is closer to 0. So I think we already have the idea that it approaches 0, right, on the parent graph. Now, going in the opposite direction, if we are dividing by 3, and so on, backwards would be multiplying by 3, multiplying by 3, multiplying by 3. So what would this next one be up here? 18. But obviously 18, it's not even, you can't even see it on the graph, so I'm not even going to use it. So we're going to graph these coordinates 0, 6. You're at the origin 0, 1, 2, 3, 4, 5, 6 right there. And then we have 1, 2, which is right there. Then we have 2 and 2/3. Let me show from the origin, 2 on the x, 2/3, it's not even all the way to the 1, so it's in between. It's close to the 1, but not quite 1. So let me put a dot right there. And we know that if you go to 3, it's 2/9, which is even smaller, and then 4, it's even smaller and smaller and smaller. It looks like it's just on the x-axis itself, even though we know it never actually touches, just infinitely approaches. So that's your exponential decay function. But that's a parent graph. That's not your actual graph. For your actual graph, you have to include this k value. Whoops.
You have to lower it 6.
Yeah, you have to lower it 6. So take every coordinate and lower it 6. So this guy, I'm going to go 1, 2, 3, 4, 5, 6, and put a dot right there. And then the next one, you're going to lower it down 6. 1, 2, 3, 4, 5, 6, and put a dot right there. So you're going to move the rest down 6. So this one that was not quite at 1, it goes down 1, 2, 3, 4, 5, 6 right here. Okay, so as you can see, I moved down 6 units, 6 units, 6 units, everything, including the asymptote. Move it down 6 units, and you'll have your end result, your final blue graph. Just connect the dots, put an arrow on it, and that's all there is to it. Put 2 X's on the parent graph so I don't mistake that for your final graph. Now we want to state everything we can, like the domain, which are your X values, which is always X equals all real numbers. The range are your Y values, Alan. And Y is what? Greater than or less than that asymptote value.
Less than.
Look, here's the asymptote value. That asymptote value is -6. And this blue line is all above that Y value of -6. So you're going to say that Y has to be greater than -6. Not less than, it's greater than. And the only other thing we could do is the Y-Intercept. Y-int, that's 0. And we ended up at the origin, right? This blue line actually crosses the Y-axis right here at the origin. So 0, 0 is your Y-intercept. And let's say you're confused about the Y-intercept because I've said, count or subtract. The easier thing to do if you're confused with the Y-intercept, if you can't see it clearly, you could plug in 0 for X, and you'd get 1 right here, and then times 6 is 6, but then include the -6. 6 take away 6 is 0. So when you plug in a 0 for X, you get out a 0 for Y. That's your Y-intercept. So number 3, once again, ignore H and K. Make an XY table. Use consecutive integer inputs. When we plug in 0 right here, we're going to end up with 3 to the 0, which is 1, but there's a negative in front, so that is -1. When you plug in 0, you get out a -1. And now at this point, you could focus in on your growth factor, which is 3. So if I take 1 and then multiply it by 3, I will get -3. If I take the -1, multiply it by 3, I'll get -3. And if I take that -3 and multiply it by 3 again, you'll get -9. And if you take that -9 and multiply it by 3 again, -27. That's way off the graph, so you're not going to use that coordinate. Now, if going this way, you're multiplying, once again, if going this way, you're multiplying by 3, multiplying by 3, you get 9, multiplying by 3, you get 27. Going backwards, it'd be dividing by 3, or times 1/3. So right here, you'd get -1/3, and then -1/9, because 1/3 times 1/3 is 1/9, and then -1/27. And you could even use the numbers. You could see that the pattern that these numbers 1, 3, 9, 27 end up going that way, 3, 9, 27 in the denominators of the fractions. Anyhow, these are your parent graph coordinates. So let's graph 0, -1, which is right here. Let's graph 1, -3, which is right here. Let's graph 2, -9, which is way down here. And let's graph -1 and -1/3. Once again, from the origin, -1 and -1/3 is just slightly down. It's not even halfway down. It's -1/3 of the way down. So it's not much. And then the next one, -1/9, it just looks like it's on the line because even though it gets smaller and smaller and closer, we can't really draw that difference. So this is our parent graph. We know that it looks like it's touching, but it never actually touches, just infinitely approaches. So the original parent graph had the asymptote right here. We know that our asymptote is actually y equals 6 because we get it from that k value. So you move it up 6, 1, 2, 3, 4, 5, 6. We know it's going to end up right here, the asymptote. And we need to move up every other coordinate 6 units. So if I go to this original coordinate, move it up 1, 2, 3, 4, 5, 6, I'll end up right there. And then if I move this next one up 6, I'll end up right here. And the other one, if I move it up 6, this last one up 1, 2, 3, 4, 5, 6, I'll end up right here. So it's all about the blue dots, that blue line. Let's connect the dots. And we know it has to go to that asymptote. Whoops, got a little ugly right there. But that's your asymptote. That's your blue graph. That's your growth function in a negative direction with the asymptote at y equals 6. State everything you can. Your domain, x values are all real numbers. Your range is y is what? Less than?
Y is greater than?
Less than 6.
Less than 6?
Yes. Because if your asymptote is right here at 6, right? Your whole blue graph is below y equals 6, so y is less than 6. And the Y-intercept value, if you want, let me write it out. Y-int, it's going to be a coordinate. We know to find the Y-intercept, you set x equal to 0. So you could use the whole thing for this one. You could plug in 0 right here. That'll be -1. And -1 plus 6 is 5. So the Y-intercept is 0, 5. So again, on number 6, the first thing to do is to ignore your k value, which is your asymptote, which is -4. Make a quick xy table. You want to use consecutive integer inputs. So you want nice numbers, -3 and in order. -2, -1, 0, 1, 2, 3. If you do not put these in order, it's not going to work out. You cannot use the growth or the decay factor. So the easiest number to plug in is 0. When you plug in 0, anything to the 0 power is 1, and 1 times 2 is 2. So when you plug in 0, you get out a 2, and that's the first coordinate of your parent graph. You could graph that if you want. I am going to. There's the coordinate 0, 2. 0 on the x, 2 on the y. Now from that point, you could plug in a 1 and work out the math and get an output. You could plug in a 2, work out the math, get an output. Or the easier thing to do is to use your decay factor. Your decay factor is 1/2. So if you take 2 and you actually multiply it by 1/2, what is half of 2? That's 1. And then if you take the 1 and multiply it by half, what are you going to get? What's 1 times half? 1/2. And then 1/2 times half? 1/4. And we already know that the next one's 1/8 and the next one's 1/16, and it gets smaller and smaller and smaller, closer and closer to 0. So once again, from here to here, you multiplied by half, multiplied by half, multiplied by half. Backwards would be the opposite, which is really multiplying by 2. So 1 times 2 is 2. So this next one is what? You multiply by 2 to get the next one up, right? So you get 4, and then 4 times 2, 8, and then 8 times 2, 16. But this is already off the graph, so you don't even need -3, 16. So anyways, those are the coordinates to your parent graph function. So let's plot them. -2, we already plotted the y-intercept on the parent graph 0, 2. Let me go for -1 and 4, which is right here. Let me go for -2 and 8. -2 on the x, 8 on the y, it's way up here. Let's go for the next coordinate, 1, 1. 1, 1 is right here. And then 2.5. That's where it gets a little interesting. Here's the origin. Go 2 on the x and then halfway up. So you're going to put a dot halfway right here. And then the next one's 1/4, closer. 1/8, 1/16, 1/32, 1/64. 1/64 is hardly anything. It's really close to 0. So your parent graph, it looks like it's touching the x-axis, the asymptote y equals 0. But we know it never actually touches, it just infinitely approaches. Now for your final graph, you need to include your k value, Andrea. And your k value is what, Esteban? You're going to take every single one of these coordinates. This coordinate, you're going to move it down 1, 2, 3, 4, and you're going to put a dot right there. And move it 4 units down. And we're going to move all the coordinates 4 units down, getting the final blue graph right here. And of course, at the end of it all, it looks like it's on your asymptote. And like you said, Esteban, the asymptote's -4. That's why this is the -4 line that your blue graph infinitely approaches. So to finish off the graph, just connect the dots, put some arrows on it, and you're good. Then you have to state everything you can about it. The domain, your x values are what? Janisa? X values for the domain. The domain of any exponential growth or decay function is going to be x equals all real numbers. Okay, that's a free point right there. Okay, the range values. Bless you. This blue line or this blue graph, is it above a certain value or below a certain value? Above. Above. What is that certain value? That's right. Y is greater than -4. What else? The Y-intercept. That's a coordinate. We already stated that the asymptote was y equals the -4. Okay, but the y-intercept is going to be 0 for x and your output for y. Now, if we look at the actual blue graph, it does cross at the origin. It crosses the y-axis at -2. So 0, -2 is your y-intercept. Now that's visually where we see the y-intercept. It crosses right here at 0, -2. But if you wanted to do it numerically, you can by incorporating everything on your original graph. So if you look at the whole thing and you wanted to find the x-intercept, you could, the y-intercept, you could plug in 0 for x and you'd get 1 times 2, which is 2, and then take away 4, that's -2. So your y value would be -2. So you could either look at it visually or you could plug in 0 for x and solve for y, which would give you -2. And that's all there is to say on number 6. On the back side, if you flip over to the back side, we are not going to be stating the range. We're just going to skip that. Don't do the range on that. Instructions on the first part from 7 to 10. Now on a previous video, I already explained 7 and 8. So right now we're going to look at 9. And it's this simple, guys. If your base is greater than 1, it's a growth function. If it's less than 1, it's a decay function. So Rosalba, is this a growth or a decay function? Growth. Why? Because that base is 3 over 2. 3 over 2 is 1.5. It's greater than 1, so it is going to grow. So on number 9, we're going to put growth. And we're also going to state the growth, the b value, the growth factor. The b value is 3/2. And it's also asking for the k value, the asymptote value. So -4. Does it ask for the asymptote? Yeah? Okay, so we want to write it as an equation. So we're going to say y equals -4. And that's all there is to say about number 9. How about number 10? Is that a growth or a decay? Growth. Still growth. It's the same exact base. It's 1.5. It's greater than 1, so it's definitely growth.
What about 7?
7? Well, 7's on a previous video, but so number 10 is growth. The b value is 3/2 or 1.5. They do ask for the asymptote, which is our k value. What's our k value? Y equals 0. There is no k value, so you just put y equals 0 as your asymptote. So that's a pretty easy section. Just stating whether it's growth or decay by looking at your b. Let's also look down here. We have several graphs. They want us to state whether it's growth or decay, and then state the asymptote, and then it says state the range. I guess if you want to do range, or let's not state the asymptote, because if you're stating the range, then you already know your asymptote, because it's either above or below that certain value. So I already explained a couple of them on a previous video. So let me jump to these two right here. So the trick to this is from left to right, if it approaches a certain value, then it's decay. But if it approaches negative infinity, see how this keeps going down, 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 way off the page, right? That is an exponential growth function. Okay, that's an exponential growth function. So, how about this? Let me do a quick mini lesson here. What does a decay function look like? If it approaches a certain value, it's a decay function. So from left to right. So let's say I have something way down here. From left to right, it's going, it's going, it's growing. It looks like it's growing, but it's not really growing. It's approaching a certain value. So that's called a decay function because it approaches the y value of 0. That's a decay function, right? A growth function either approaches positive or negative infinity. It does not approach a specific value. So a growth function, it could be starting off at nothing and then it grows, right? Or, let me erase that. Or you could be starting off at a certain value and then it grows but in a negative direction. So if it grows up to positive infinity, that's growth. If it grows down to negative infinity, it's still growth, okay? From left to right, it's kind of like reading a sentence. You have to look at it from left to right. So if from left to right, it's growing to positive infinity or negative infinity, that's obviously growth. But let's say from left to right, you have something way up here, and then it approaches a certain value. Let's say it stops at that value. So that's a decay function. Because from left to right, it's approaching the value of, that's probably x equals, or y equals 3. Okay? Okay, so check this out. From left to right, is it approaching a certain value? No, it's going to negative infinity. So that's why it's growth. Okay? Now, the asymptote itself is at y equals 0. So the range would be y is less than 0 because your asymptote's 0. So check this one out. From left to right, is it growing to positive infinity or is it actually decaying to a certain value? It's decaying to a certain value. And that certain value is what? I just drew a blue line right there. What's that certain value? 2. That's what it's decaying to. So this is definitely a decay function. And your asymptote is 2, which means that your range is y is what? Less than what? 2. There you go. That's all you have to do. How about this guy right here, guys? Is this a growth or a decay from left to right? That's a decay. Now, don't say that it's a decay because it's going down. That's not the case. It's a decay because it approaches a certain value. What's that value it's approaching? Negative 3. That's right. So this is a decay because it approaches a certain value, and that value is the asymptote negative 3. Now, if I wanted to talk about my range are going to be my y values, and this, what is it? Y is greater than negative 3 or less than negative 3? Greater than negative 3. Okay? What do you guys think? Okay? The more you practice, the easier it gets. Now this bottom part, I want you to look at these XY tables. I want you to analyze them. And that way you could determine if it's an exponential growth function, exponential decay function, or if it might not be exponential growth or decay, it might be linear. Okay? So in order for it to be an exponential growth or decay, it's kind of like if you're multiplying by something or dividing by something. But a linear function, it might look like it's growing, but it's really not growing exponentially. It's growing like as a line. It's like with a constant. So I explained this on the other video. I might as well explain it again. On this table right here, is this exponential growth?
Yes.
Okay, it's not exponential growth. It's a line. Okay. Now, why is that? Because 0 plus 4 is 4. Plus 4 is 8. Plus 4 is 12, right? But exponential growth is multiplication. It's where you have something times 4, times 4, times 4. So this is not exponential growth. This is just linear. I mean, I guess you could say linear growth, but it's just a line. The difference, there's a common difference. From here to here, it's adding 4. From here to here, it's adding 4. From here to here, it's adding 4. And that's not what happens on exponential growth functions. On exponential growth functions, you either multiply by a value or divide by a value, which is multiplying by the fraction. So let's take a look at this next one. They don't even have numbers on them. But this one right here, since the inputs are in order, now we can look at the outputs. From here to here, what's happening? From here to here, what's happening? And what's happening? It's growing, definitely. Now, is it growing by adding or is it growing by multiplying by something? By multiplying, right? So that is an exponential growth, but you need to make sure that it works on all of them. So if I take 3/4 and multiply it by 2, will I get 3/2? Yeah, because the 2 over 4 cancels and you end up with 3/2. And then if I take that 3/2 and multiply it by 2 again, will I get 3? Yeah, because the 2 cancels and you end up with just a 3, right? And then if I take 3 and multiply it by 2 again, will I get 6? Yeah, so this one for sure is growth. This one for sure is growth. And the growth factor, the base, is 2. It's growing by 2. So keep in mind, guys, lines, yeah, it might look like it's growing. And it is growing, but it's growing at a linear rate, not an exponential rate. Okay, so it's growing by adding 4. But right here, this is actually exponential growth because we're multiplying by 2. Okay. So how about this guy right here? From -3 to -1, is it growing? Is it decaying? Neither? What do you guys say? Okay, is it growing, but is it an exponential growth? No, it's not exponential. So this is what? Linear. It's definitely a line. Now remember, in order for it to be exponential growth, you have to multiply it by a certain value to get to the next output. Okay. Over here, this last one. Is this exponential growth, exponential decay, or is it linear, or is it neither? None of them.
It's exponential.
Exponential growth? Because if you look at 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So we're thinking exponential. But look at all these x's. These are all messed up, right? So you can't analyze outputs unless your inputs are in consecutive integer order. That's why it's so important that these guys are perfectly in order. Like over here, we have the -2, -1, 0, and 1. So those are in order. These are not in order. So you can't even analyze this. So you would just say neither or none. That's just a relation. Who knows what that is, right? I'm done.